Hello everyone. My name is 廖义华 and I'm from 统知市 and I will present the result of my final report for the data mining. Let's start with the source and the metadata of the data set used in this report. The data is sourced from the US government's open data platform contains 390 records and 13 variables. The target variable estimate represents suicide rate category into low, medium, and high for easier analysis. This study focused on analyzing suicide rates across different demographics to derive actionable insights for public health policy and intervention. Here's an introduction to the variables in the data. These variables help uncover patterns and insights reliable to suicide rates across various demographic groups. Next, discuss data processing. I address missing data in the estimate column by replacing it with the median within each subname group. A median being robust against outlier. Ensure that the distribution and relevance of the data were preserved. I also remove unconstant columns such as those with fixed value, redundant information, or mostly missing data. This change cleaning out focus the data set on related variables for better analysis. For the data decryption process, we transform the estimate column into three equal frequency categories: low, medium, and high. This was done using context-based bidding, and the result was stored in a new column called estimate level. And as for column splitting, broke down the start label column into multiple secretaries like category 2, and so on, using the column splitter list. Help us better organize and analyze the data. Here's the process code. And one hard encode was used to convert category variables, such as age in category 2, category 4 into binary representation. This ensures compatibility with machine learning algorithms. And the age variable represents age range, like 15 to 24 years or 25 to 44 years, which made its category covering this variable allow for accurate and unbiased model training next is decision tree. I split the data set reserving 20% for testing, and the decoded and encoded process was done and mentioned earlier. For feature selection, I used two methods: the charcoal test, which scans 6 feature and selection model, which select 7. From the chart, we can see that female was a significantly important feature. Comparing the accuracy, the 7 features chosen by model show a higher accuracy. Next, I model with these 7 variables, testing across interval of m equal 2 to 10 and equal 0.0 to 0.25. The best parameter was equal to 0.0 and m equal 10. Testing accuracy is 75.2%. For C.4 to point with C equal 0.25 and M equal 10. Testing accuracy of 73.98%. In four-variable modeling, testing in the same ranges. And interpret slightly output Jenny. The best parameter was 3, 4, C equal 0.05 and E equal 2. And testing accuracy is 74.06. Four variable had a higher accuracy, but the leaf and tail of the tree was too large. Therefore, I choose the variable model with higher accuracy. And in the final model, there are 14 leaves and 3 size is 7. From the result, we can see that a red line, when female and black on occurring amendment are all white. The estimate level are medium. Then we can see the blue one. Female and black or American are all 0. For 10 to 14 years is when the estimate levels are low. The yellow one, female, black, or African American 10 to 14 years. Asian or Pacific is are all 1 and white is 1. The estimate level are high. This using the 5-fold cross validation showing the accuracy of the classifier was 72.11%. Then I'm talking about association rule in RISC-R. The design in encoding process was done as mentioned easier. And I set up support for 0.01 and confidence for 0.5. We can see that 38 rows in RStudio. To choose the row that I want, sort by confidence from high to low, we can find 3 main rows. First one, when American Indian or Asian native 35 years over are yes. Mentioned to medium, then to 10 to 14 years are yes, mentioned to low. 75 to 84 years are yes, mentioned to estimate level high. Next is the part of SVM analysis. As mentioned earlier, encode a canary variable and desert year column into decade. I split the data set, reserving 20% for testing. Additionally, due to the wide range of years, I standardize the data. Then this slide shows the training and testing accuracy of SVC and linear. This higher accuracy was achieved when the parameter was set to 0.21. In a closed storage evaluation, SVC higher. Therefore, I choose the SVC model with an gamma set to 0.21 as the final selection. Random forest. In random forest, the decrementation and encoding are same. As mentioned earlier, data splitting 2 and we don't need to data standardization. Cost of random forest model is not sensitive to number. In the first model, I choose 3. Parameter and n estimate equal 100 and max defense equal 10. And the random state the accuracy of 85.73. Then I set them in alternate to 50 and 150. Max them equal 10 and 12. Comparing four model I used. The model 4 with an estimator equal 150. And max them 12 had the highest accuracy. And then let's introduce KNN. This decrease the differentiation and encoding are the same. As mentioned earlier, data splitting too. Due to the wide range of years, I standardize the data. Certainly using loop. Select a changing number of neighbor k from 1 to 50. To obtain the best k will be 5. When using the optimal number of neighbors, the testing accuracy is 1925, 1961, and the training is of 92.43%. Next is ensemble linear learning. Using the best accuracy obtained from different models earlier, the parameters are fit to the ensemble model. The result in a test daytest. Accuracy is 89.75 for soft voting and 89.44% for hard voting. Next, let's compare the result of decision tree SVM. Random forest KN and soft voting among them, KN achieved the highest accuracy. In this selection, talking about K-mix. Using the screen plot, we can see the cluster of 3 and 7 hard Newton decrease in SSE, so I choose them for clustering. Comparing two clusters had higher accuracy and smaller SSE. Then I add a target variable, which the estimate level was the same as the previous step. 7 clusters chosen because of smaller SSE. Based on the result obtained from the previous two criteria, the K with the smallest SSE was chosen as the final number of clusters. Learned to as the 7 cluster. I also obtained the result of clustering and short routing of each category. Take cluster I for example, which year is 1980s, age is 55 to 64 years. 6 is male, race is black, and ethnic origin is known. The estimation level would be medium. Then I assign marketing name for each cluster. I consider of the result middle age calendar, which estimate level would be medium. Cluster 2 consists of modern woman sex, which estimate level would be low. Cluster 3 consists of young for explorer, which estimate level would be low. Cluster 4 consists classic middle age protector, which estimate level will be medium. And cluster 5 consists ambition travel belly, which estimate level will be high. Cluster 6 consists of modern aesthetics travel, which estimate level would be high. Cluster 7 consists of wise Asian elder, which estimate level would be medium. The accuracy based on major voting in each cluster is 60 to 21%. The accuracy and the final selection is the conclusion of these reports. But SKN stand out of the best clustering model. For the data achieve a high training accuracy of 92.43%. And testing the accuracy of 90.61%. Outer models, while SVN and random forest also perform well. KNN generalized was superior. The decision tree thought interpretable. It had a lower testing accuracy of 75.2%, making it less suitable for soft voting ensuring SVN. Random forest and can achieve 89.75%, citing below can alone. And occlusion KN is the most exact model planning accuracy, simply and performance. Additional K-means clustering provide key devoring insight to inform targeted public health strategy, increase the value of data-driven approach. And thanks for teaching. Have a nice day.